What's up, guys? Welcome back to the Calc channel. Today, we're going to be starting our series on key things that you guys wanted me to review for the AP exam. And guys, today we're starting off fresh with something that you all asked me to cover. And what you guys asked me to cover was practicing using integration with long division and completing the square. So that's what we're going to do. I'm going to try and keep this video as short as I possibly can. We're going to cover both of those topics in this video. So before we get started, if you want to see more videos like this before you go take that AP exam, make sure you subscribe and click that little notification icon. Probably would be down right about there, or maybe my camera's being mirrored, so maybe it's over here. It's somewhere down there. Go ahead and leave a like, comment. Tell me what you guys want me to go over in this series. And yeah, we're going to jump right in with long division first, and then we'll jump into completing the square. So I'm going to do it as fast as I can. Let me pull up my paint pad, and let's get right into the video. Alright guys, the first thing we're going to do is we're going to go ahead and we're going to take a look at, hold up just one second. We're going to be going ahead and we're going to be taking a look at completing the square. I completely lied to you guys. I said I'd talk about long division first, so let's stick with it and talk about long division first. Please forgive me. So over here, I've got an integral that I'm going to ask you to calculate, and a lot of you guys are going to be like, oh, I'm going to jump to my calculator, and to which I would reply, well, you're not going to be able to do that really easily considering the fact that this is an indefinite integral and there are no limits of integration, so your calculator's not going to be able to save you here. So my first tip to you is always look for other ways to see if you can simplify this integral. Can you split it up in some interesting way? Is there any use substitution that you can do? Integration by parts, partial fractions, and then resort to long division and completing the square. Don't think when you look at a problem, long division and complete the square, because more often than not on the AP exam, that's probably not the best way to do the problem. Always think first, use substitution, integration by parts if you're in BC, integration by partial fractions if you're in BC, or any other method of integration before you think about doing long division or completing the square. We'll talk more about that strategy at the end of the video, but of course, you all know that you're going to have to solve this with long division, so let's go ahead and get into it. What I think the problem is with long division that students get scared about, I don't think it's the math per se or the calculus. I think that they understand the calculus and can do the calculus. I think the hard part for them is maybe A, identifying when they should use long division, and B, just remembering how to do long division in the first place. So a big giveaway for me to know that I'm going to have to use long division is if I've got a fraction, I've got a rational function in here. A rational function is the function, is the fraction basically, and it's got numerator, it's got some equation, and the denominator, it's got a different equation. Now specifically, I'm probably going to want to use long division if the numerator has a greater power than the numerator in the denominator. And obviously this is x to the 1. 2 is greater than 1, so I'm probably going to lean more towards using long division on this type of a problem. So when you're looking for long division, make sure you've got a fraction, because remember, a fraction can also signify division, and make sure that the numerator has a greater degree than the denominator. With that being said, let's go ahead and set up our long division problem. So this is how I went and set up the long division problem on the side of my paper. And you guys are probably thinking, Trevor, why the heck did you include a 0x in the middle? And to that I say, well, you can't leave out any part of the function. So what do I mean by that? That was really a terrible way to phrase it. But what do I mean by that? Well, you can't, there's an x term here. You have to have every single power of x, or every single power of x included, from the biggest power all the way to x to the 0, all the way in between. You've got to have everything in there. So even though this never had an x term in there, there was no x term in there, we have to include it in our long division over here. That's really important, or else you actually start getting the wrong answer. So make sure that even if it's not included over here, that you include it inside here when you do your long division, or else you're going to get the long division completely wrong, and you're going to get the whole problem wrong. So with that being said, let's go back to our Algebra 2 review and see if we can solve this in any way. So let's go ahead and take a look at, oops, I want to change colors here. Let's go ahead and take a look at this first term right here. So remember, when you're doing long division, you only look at the x in terms of the first step, and then you look at the x plus 1 as a whole. So first off, We're just looking at the x. So how many times does 2x squared go into x? Well, I'll think about it. What times x is 2x squared? So what times x is 2x squared? Well, think about it a little bit. Obviously, we divide both sides by x, divide both sides by x. There should be a 2x that goes right here. So x goes into 2x squared 2x times. So how would you simplify that? Well, of course, you'd multiply the 2x squared by the x. That is obviously, we just did that. That's a 2x squared. And then 2x times 1, that is a positive 2x. Now, this next step, remember, you want to make sure that the highest degree is always canceling out. Now, sometimes if this highest degree is negative, normally you're taught when you're doing long division that you always subtract, but because of the variables, you might have, say, a negative 2x squared here, in which case you would have to add in order to get them to cancel, not subtract. My point is, in this case, we're going to end up subtracting, but just keep in mind that you may not always be subtracting. You may have to do addition in order to get the highest degree term to cancel. In this case, we're going to do subtraction, so these obviously are going to cancel, and we're going to be left with a negative 2x, and obviously the 1 is going to come down. So we're going to have a negative 2x plus 1. So now let's keep going here. X goes into, let's change colors. X goes into negative 2x how many times? Well, negative 2, because negative 2 times x is negative 2x. So negative 2 times x, obviously we just said that, it's negative 2x. And then negative 2 times 1, that's negative 2. And we want to get these to cancel. So what if we do this? If we subtract it, what's going to happen? Well, we're going to distribute the minus through, so the minus will become plus, and this will become a plus technically. So really what we're going to do is we're going to end up adding both of these when we distribute the subtraction through. These will cancel. They won't cancel, excuse me. They'll add to 0, technically is what's happening. They're not canceling, quote unquote. And then obviously this is going to add up to 3. And so that's the remainder. 3 is our remainder. So now we can rewrite this. We can rewrite this integral as the integral of, well, we got our answer being 2x minus 2 dx plus the integral of this remainder. And how do you write the remainder? Well, you write the remainder in the numerator and what you're dividing by in the denominator. So 3 over x plus 1 dx. And just for kicks and giggles right now, you see that 3 there. I'm going to pull it out because it's a constant. Remember, we can pull constants out front. So we're going to get a 1 over x plus 1 dx. And now this is a matter of calculus. You guys can do this calculus so easily. Take a look at this first integral. You guys, boom. Reverse power rule on the first one. The x is going to bump up to an x squared. Of course, you've got to divide by 2 because the power is 2. That's how that reverse power rule works with integration. Obviously, when you divide by 2, it's going to cancel with the 2 that's right here. So you're good to go. It's just going to be an x squared. And obviously, if it's a minus 2, we're going to bump it up to a minus 2x. Over here, though, it's going to get a little bit complicated. We can, in our head, picture this as a u substitution, where u would be x plus 1. So then du would be 1 dx. So that means we could rewrite this as a 1 over u du, and sorry, I'm being really sloppy right now because this is a pretty basic one that I think you guys can all do in your head. So we got a 1 over u du. The derivative of that is the natural log of the absolute value. So we're going to add to it. I'm going to change to white here. We're going to add to it 3 times the natural log. I'm going to substitute u back in, the natural log of x plus 1 plus c. It's an indefinite integral. Do not forget your plus c, or else you're going to lose points, you guys. Don't forget your plus c. And that is our final answer. Oops, I didn't mean to do that. And that is our final answer. Now, if this stuff was confusing to you guys, I recommend you go check out Khan Academy, go check out an AP review book, but I recommend you go check that out because that's not the point of the video, this u substitution. So if that was confusing to you, I'd recommend going back and watching u substitution videos on YouTube. Just go to YouTube and type in u substitution for integrals calculus, and I'm sure you'll find something. But that was not the point of the video. But the point of the video was to show you guys, review the long division and how you could use long division to simplify a giant expression like that. Not that hard. I think, again, the students' hardest part is identifying when to use it. You use it when you got a fraction and the numerator has a higher degree of the power of x than the denominator, and also just remembering how to do that algebra skill of long division. I think you guys got it. So without further ado, we're going to go ahead and move on, shift gears. Hopefully I can do this fast. We're going to shift gears and we're going to talk about completing the square. Actually, I'm going to do completing the square in another video, so stay tuned for that video when that video comes out, because I want to go over this part of long division really, really quickly. Some people would ask, okay, Trevor, remember synthetic division and all that fun stuff? Remember how synthetic division was so much easier and so much faster than long division? Could I use synthetic division instead of long division when simplifying these integrals? And my answer to that is yes and no. So you've got to understand when you can apply synthetic division and when you can't apply synthetic division. And how do you know when you can apply synthetic division? Well, you know you can apply synthetic division if the degree that you're dividing by is 1. You can only do it if the degree is 1. If it's an x squared, an x cubed, or anything higher than that, you cannot do synthetic division. You can only do synthetic division when what you're dividing by is of degree 1. It's x raised to the first power. The other catch you have to make is that a lot of students make the assumption that 1 is going to go in this little box when you do synthetic division. No! 1 does not go in that box. -1 goes in that box. Whatever goes into the box is whatever you would solve if you set what you're dividing by equal to 0. So if you set x plus 1 equal to 0, or you set whatever it is equal to 0, x plus 3 halves, any of it, whatever you get when you set it equal to 0 and solve for it, that is what you put in the box. So we're going to put that in the box. So let's make our setup real quick. So -1 is going in the box. And let's remember, we just list off the numbers. So we've got 2, we've got 0. There's no x term, so we got to put a 0 there for the x term. And a -4. Pop these out. This is going to become a remainder. 2 is going to come down. 2 times -1 is -2. -2 and 0 is obviously -2. -2 times 1 is 2. And -4 plus 2 is -2. Now, I'm noticing that as I did the synthetic division, I clearly did something wrong somewhere along the lines, and I don't know where exactly I went wrong, but that's not the point. The point that I wanted to show you is that you can use synthetic division and then simplify the integral out in that way. Synthetic division works, but remember, you can only do synthetic division when when the degree that you're dividing by is of degree 1. So without further ado, that's all I wanted to cover in this video. That was on long division. You guys, if you just can't get long division and it's just not making sense, you guys, I would not freak out about the fact that you can't get long division. I would be very surprised if they asked you to do long division on the free response section. That would really surprise me if you had to do a solving an integral via long division on the free response section of the AP exam. That, I don't think you're going to do it on the free response, and there might be 2, 3 multiple choice questions on it. 2 or 3 multiple choice questions, nothing. This is not going to ruin your score. So if you cannot get this concept, there are other concepts you can get, and if you're only losing 2 points because you can't get 2 multiple choice questions because you can't do the long division, it's not the end of the world. So it's not the end of the world if you can't get this concept. That's all I'm going to say. If you get it, awesome. If you don't, and it's like 2 days before the test, don't freak out and don't try to spend a ton of time understanding it. Just let it go. Let it go. Take a deep breath. Let it go and move on. It's 2 multiple choice questions. You'll be fine. Without further ado, thank you guys so much for watching. Come back for my completing the square video. And yeah, I'll see you guys in the next video. See ya.